Right. O and Q is a sector of a circle with a centre O and a radius of 11. A is on the point ON and B is on the point OQ, such as AOB is an equilateral triangle side of 7. I'm going to start putting in numbers. So I know this is an equilateral triangle. It says side of 7, so I know this is 7 centimetres. I know that's 7, I know this is 7. Let's try it in. 7 centimetres, 7 centimetres. Oh, and actually no, the radius is 11, so I actually know this one here is 11. Okay, right, let's need to calculate the area of the shaded region, okay, as a percentage of the area of the sector OQN. Give your answer to one decimal place. Right, there's a lot going on here. So what I'm actually going to do is I'm actually going to work out the whole sector. Then I'm going to work out the triangle. Then I'm going to subtract the triangle from the whole sector. And I'm going to work this bit as a percentage of all of it. There's quite a lot going on. So let's just do the area of the whole sector first. Okay. Now you've got to think back. When I like to do with all my sectors, I like to think about the original formula, which I like to think of it as sector over all. So essentially what this means, it means that the area of the sector is the same as over the area of the whole circle, is the same as the arc over the perimeter of the whole circle, which is the same as the area of the sector over the area of the whole circle. Now, because this is an equilateral triangle, we actually know this one here has to be 60 degrees. And we need this. So we know that the angle of the sector over the angle of all of it is the same as the area of the sector over the area of the whole circle. Now, because we know the radius is 11, and we know the formula is pi squared, we know the area is going to be pi 11 squared. Okay? I know what pi 11 squared is. I've typed in my calculator. Pi times 11 squared. So I know this is 121 pi. So all I need to do is solve this. To solve this, I need to times both sides by 121 pi. So if I do 60 over 360 times 121 pi, that means my area is 121 over 6 pi is my entire area. Okay, so that is the area of arc. So area of the segment. That's all of it. Now I need to try and work out the area of this triangle. Now when you think of triangles, you do base times height divided by 2. I've got my base, but I don't know my height. We can work out the height because I could just do a little dash thing, do a right angle triangle, and then I could do a c squared take away a squared, which would be 3.5, and then square root my answer, get that. Or I can just cut through all of this and I could just use my trig. Okay, and my trig is actually half AB sine C. Okay, half stays as a half because it's an equilateral triangle. A is 7, B is 7 because they're the same. Times by sine of 60. I'm just going to type that in my calculator. So half times 7 times the sine of 60. Let me just make sure I'm in degrees. I am. My answer is 49 pi, but I'll just write it as 21.217. Okay. So I'm going to write this down here. And my triangle equals 21.217. I know my segment, okay, equals 121 over 6 pi. Okay, but I need to know this little bit here. So I need to subtract the bigger one from the smaller one. I'm going to change my 121 over 6 times pi into a number, just so I can deal with it. 63.355. So I need to take this away from that. A minus 21.217. So I know my little shaded bit is actually going to be 42.138. Okay, centimetres squared. Well, I've been lazy. Now it doesn't want this. It wanted the area shaded region as a percentage of the total area of the sector, not of the circle, just of the sector. So I need to do my area of the sector, which 138. I need to divide it by the area of all of it, which is this number here, okay, which is 63.35. And your times by 100 because it's a percentage. So calculators are good these days if you type them in properly. Times by 100. I got my answer is 66.516%. It did say to one decimal place though. So I need to change that to one decimal place, which is here, which is easy, 66.5%.